For generations, we called Jupiter a gas giant. Now we know that description barely scratches the surface, because Jupiter may not truly have one. That is the first strange thing about Jupiter. Not its size, not its storms, not even the Great Red Spot. The strangest thing is that if you tried to stand on Jupiter, there would be nowhere to stand. You would keep falling, down through cloud after cloud, into darkness, into pressure, into a world where matter itself begins to change. And the deeper we looked, the more Jupiter stopped behaving like a planet we thought we understood. From Earth, Jupiter seems almost simple. A striped sphere, bright, massive, ancient. It has watched humanity since before the first telescope. A steady light in the night sky, moving with the wandering planets. But simplicity was an illusion, because Jupiter is enormous in a way the human brain struggles to hold. It is more massive than every other planet in the solar system combined. More than 1,000 Earths could fit inside it. If Earth were a grape, Jupiter would be closer to a basketball. And yet almost everything we can see is only the beginning. Its visible face is made of bands of cloud, stretched by fierce winds that circle the planet at tremendous speeds. White, brown, orange, cream. At first glance, they look like painted stripes, but these are not markings on a surface. They are weather, planet-wide weather, rivers of atmosphere wrapping around a world so large that entire Earth-sized systems could disappear inside a single turbulent region. And then there is the Great Red Spot, a storm so vast it has become iconic. For centuries, astronomers have watched it turn with the planet like a wound in the clouds. On Earth, storms are brief things. They form, they move, they die. But Jupiter does not always follow the rules we know. This storm has endured for generations, a rotating monument to a planet powered from deep below. But that alone would have been unusual. It was only the beginning. For most of modern history, the standard picture seemed reasonable. Jupiter formed early. A dense rocky core grew large enough to pull in huge amounts of gas from the young solar system. Over time, that gas built the giant world we see today. Clean, logical, comforting. The problem is that Jupiter did not stay inside that explanation. Every mission to the planet chipped away at it. First came distant images, then close flybys, then direct measurements. And slowly, the giant planet began revealing a much stranger interior. The turning point came with violence. In 1994, a comet named Shoemaker-Levy 9 plunged toward Jupiter after being torn apart by the planet's gravity. Not one object, many. A broken chain of icy fragments, all on a collision course. Over several days, piece after piece slammed into the far side of Jupiter. The explosions were colossal. Dark scars larger than Earth spread across the cloud tops. For astronomers, it was a rare accident of cosmic timing, a natural experiment delivered by the solar system itself. And it exposed something important. The impact stirred up material from beneath Jupiter's upper clouds. Suddenly, scientists were not just looking at the surface appearance of the planet. They were seeing clues from deeper layers. Among those clues was water. More water than expected. That mattered because water is not just another ingredient. It helps trace how planets form, how material mixed in the early solar system, and what Jupiter may have gathered during its birth. The comet impacts did not solve the mystery. They sharpened it. What exactly was hiding below those clouds? Later missions pushed that question further. Galileo entered the Jovian system and studied the planet up close. Then Juno arrived decades later with instruments designed to probe beneath the visible atmosphere. Not with cameras alone, with gravity measurements, magnetic mapping, microwave sensing, tools built to investigate what the eye cannot see, and what they found forced a rewrite. Because Jupiter is not mostly what it appears to be. The cloud deck we see from space is real, but it is shallow. On a planet nearly 140,000 kilometers wide, the visible upper atmosphere is more like a skin than a body. Within those upper layers, temperatures are brutally cold. Ammonia and water help build towering cloud systems. Lightning flashes through the gloom. In some regions, rising material and sinking material create enormous cells of motion, like weather engines scaled up to planetary size. But underneath those clouds, the environment begins to transform. Fast. As you move downward, pressure climbs. That pressure is created by Jupiter's own immense gravity, squeezing the layers beneath it. On Earth, gases usually remain gases unless they are cooled enough. Inside Jupiter, the opposite path dominates. Compression. Relentless compression. Imagine descending through fog that becomes thicker and thicker, denser and denser, until it no longer behaves like air at all. That is the mental model. Except this fog is mostly hydrogen. Hydrogen is the simplest element in the universe. A star is built from it. Interstellar clouds are filled with it. Most of the visible matter around us traces back to it. But inside Jupiter, hydrogen is forced into conditions almost impossible to reproduce on Earth. Deep below the clouds, the pressure becomes so extreme that hydrogen is no longer free to drift as a gas. It condenses into liquid, not because the environment is cold, because the weight above is crushing it into a new state that changes everything. At that point, Jupiter stops looking like the textbook image of a gas giant, because below its outer atmosphere lies an immense ocean of liquid hydrogen. No shores, no waves in any familiar sense, no boundary you could call a surface. Just a vast planetary interior, transitioning from gas-like behavior into liquid under impossible pressure. This is the closest Jupiter comes to having something like an ocean. And it is larger than any ocean in the solar system by an absurd margin. But deeper still, the planet becomes stranger. Much stranger. As the descent continues, pressure rises to millions of times that of Earth's atmosphere. Temperatures soar to thousands of degrees. Under those combined extremes, hydrogen crosses another threshold. Its electrons begin to move more freely. The liquid becomes electrically conductive. Hydrogen becomes metallic. Pause on that idea. The most common element in the universe, normally a light, invisible gas, transformed into a liquid metal ocean inside a planet. It is one of the most exotic environments in the solar system. This metallic hydrogen is not a thin layer. It makes up a huge fraction of Jupiter's interior. And because it conducts electricity while the planet rotates rapidly, it helps generate Jupiter's magnetic field. That field is enormous. So enormous that planetary magnetic field almost sounds too small for it. Jupiter's magnetosphere is a vast electromagnetic structure stretching far into space, trapping charged particles and shaping the environment around the planet and its moons. Invisible, but immense, a giant machine powered by a hidden ocean of metallic liquid. At that moment, Jupiter stops feeling like a simple planet. It starts feeling like a physics laboratory the size of a world. And then comes the core, the place where the old picture should have become clear. If Jupiter formed around a dense, solid seed, there should be a relatively compact core buried at the center. Rock and metal, heavy elements settled inward. A firm answer. But Juno's data suggested something more complicated. Instead of a sharply defined center, Jupiter appears to contain a diluted inner region. A fuzzy core, not a neat ball, a blurred one. The phrase sounds soft. The reality is not. A fuzzy core does not mean weak or vague in the everyday sense. It means the heavy elements at Jupiter's center may be spread through a vast region rather than packed into a compact boundary. Rock, metal, hydrogen, mixed, layered poorly, or not layered cleanly at all. It is as if the deepest part of Jupiter never settled into the orderly structure scientists expected. And that raises a dangerous question for the old model. If the core is not what it should be, did Jupiter form differently than we thought? One possibility is that early Jupiter suffered a catastrophic collision. In the chaotic youth of the solar system, giant bodies were still moving through unstable orbits. A large protoplanet may have slammed into Jupiter while it was still forming. The impact could have stirred the deep interior, scattering heavy material and diluting the core. The idea is dramatic, maybe too dramatic, because simulations suggest that even after such a collision, Jupiter's interior might eventually settle again. Yet the fuzzy structure seems to remain, so the mystery survives. That matters far beyond Jupiter itself. Giant planets are not rare. We now know of countless worlds orbiting other stars, including many enormous planets unlike anything close to Earth. Some are larger than Jupiter. Some orbit shockingly close to their stars. Some may have formed in ways we still do not understand. Jupiter is the nearest example of giant planet physics we have. If we cannot fully explain the one in our own solar system, then our theories about planets across the galaxy may still be missing something fundamental. That is the larger implication. And it is a big one. Jupiter is not just a world of storms. It is a record of formation, a compressed archive from the earliest solar system. Its composition preserves clues about what materials existed near the young sun. Its structure preserves clues about how fast giant planets grow. Its core preserves clues about whether planetary formation is orderly, violent, or something in between. In that sense, Jupiter is not merely the largest planet. It may be one of the most important. Because hidden inside it is a story about how worlds begin. And still, after all our spacecraft, all our equations, all our beautiful images, the planet refuses to become simple. Its clouds are thinner than they look. Its interior is deeper than intuition allows. Its hydrogen becomes liquid, then metallic. Its center dissolves into uncertainty. Jupiter has the shape of an answer, but the behavior of a question. And that may be the most fascinating thing about it. Because the giant world hanging bright above Earth is not just another planet in the sky. It is a reminder that the universe can hide its strangest truths inside the most familiar objects. And if Jupiter still holds mysteries this deep, what else across the galaxy have we misunderstood in exactly the same way?